Hi, welcome to the Signal Path. I have another repair video for you guys, and this time it is a Siglent, there we go, portable oscilloscope. This is a Siglent SHS810, which is a 100 MHz 2-channel 1 GS sample per second oscilloscope, plus of course the multimeter function, and it looks almost brand new. It still has the LCD cover on it, but it was listed as not working and as damaged, and it has all of its accessories, the probes, the power supply, and everything. It comes with it on the manual and the warranty card, so it's essentially a new unit, but something has happened to it and it's been damaged. And in this particular one, actually, my girlfriend wants to fix it, but she's too shy to appear on camera, so she's going to work with me and we're going to fix it in the background. So the credit goes also to her if we can fix it, and if we can't fix it, then she's the one to blame. Pooch you. So let's take a closer look at this unit. I like this, the weight size ratio of this. I think this is a nice portable unit that can be easy to use around the field. It has a nice handle and everything, and of course all the multimeter components are in the front. It's rated to DC 1000 volts. It's Cat 3 rated, okay, and it's got the common. It's a little bit, the coloring scheme is really unusual because the common here is red, and then this one is black. It doesn't make any sense, these colors, not to me at least. But it has a 10 amp input here for measuring current, and it's unfused on the 10 amp. That's pretty risky. And then there's a 600 milliamp one which is fused. And of course the configuration here has soft button keys F1 to F5, which interact with whatever menu that appears on the screen. You know, directional pads and menu buttons and scope meter and recorder. And you may seem familiar, and that's because it is familiar. And this is my Fluke 190C, which is a 200 MHz 2.5 GS sample per second. It has a very similar layout. So clearly this is the layout that's been working and people have been comfortable using. So Siglent has in a way emulated that because it works well. You can see that the order of the buttons is the same, direction pad and soft key buttons, and it's a reasonably logical, rational kind of layout. The voltages being adjusted on each channel separately, the time scale here, and moving the cursor back and forth, so it kind of makes sense. But anyhow, this is we're going to focus on this and not on the 190C, but I'm going to plug it in, turn it on, and see what it looks like when it's turned on. Alright, I think the battery has enough charge. Actually, let's go ahead, turn it on, and see what happens. There it is, Siglent handheld digital oscilloscope SH810 with the website. It's still going. Come on, what are you doing? Seems like, there we go. There it is. It looks okay. Booted up into the oscilloscope. I can see the two traces on top of each other, red and blue. And if I press meter, there you go. Here's a multimeter function. So I don't exactly know what's wrong with it. So we're gonna have to play around and see what's going on. Now there's the menu. I guess I can enable and disable the menu as well. So it's a pretty straightforward. I think the easiest thing to verify is to take a look and see if the multimeter works. And because generally the multimeter circuitry is completely separate, except for the portion where the OS is interacting with it, than what is inside. And look, the colors here. This is red, black, red, and this here is red, black, red. It doesn't match. I don't know why. Maybe someone has taken it apart and these color things this come off and we can switch them. Well, anyhow, when I take it apart, I'll find out if it can be switched or not. But anyhow, first let's go ahead and try out and see if the multimeter works. It should be easy just to plug it into something and try it out. Alright, let's measure some voltages. I like the fact that when you select different functions, it will automatically tell you where you have to plug it in. That's pretty useful, especially since the colors don't match. For example, if I go from DC volts to, let's say, DC current, you can see that it will switch it around to the two outer ones if I'm on a 10 amp range, and if I go on the milliamp range, then it goes on to the close one. So that's very helpful, especially if you haven't ever used one of these before. So let's put it back onto the amps range, and let's go back. Actually, I want to measure DC voltage. There it is. So this is my power supply over here, and I'm going to set the power supply to, let's say, 10 volts, or let's say 5 volts. There we go. This is the Rigel power supply. I'm going to enable the output. What do we see? There we go, 5 volts, 5.011. Well, it seems like a little bit off. I know that the power supply is pretty accurate. Maybe it's a little bit out of cal, but it's okay. You know, 5.09 is fairly close. I'm not unhappy with that. We can also try and measure the current. I can just go ahead and short it on the 10 amp range simply because it doesn't matter. It can take up to 10 amp and the power supply is set to 1 amp. Let me go under DC current there, and it's now telling me to connect it across here. There we go. It should be 1 amp and it's 0.989, and the regular power supply says 1.001. So I think it's a little bit out of cal, but I cannot find anything specifically wrong with the functionality. It seems like it's fine. Let me disconnect it from the power supply. Let's go back to the main unit and let's go to resistance. There we go. Kilo ohm, mega ohm. Yep, I'm going to short the outputs together. There you go. It's auto ranging. There you go. 0.2 ohms. That's about correct. So I think it's fine on the multimeter. So whatever the problem is, it must be. I played around a little bit more with it as well. I think it must be on the oscilloscope part. So let's go ahead and try the oscilloscope. If I go back to the scope, it looks okay. So let's take a look at the probes. So these are the supplied probes that come with this unit, and they have ×1 ×10 selection switches, which is nice. General quality, I'd say it's pretty good. Nice soft cables, and it's pretty good, I think. But you know, I was looking around and I was just about to use them, and I took these off, and let me show you what I found. Look at this. You see what has happened? I think this is our clue on what has gone horribly wrong with this poor instrument. You see that? That is a lesson in oscilloscope common grounds between the channels. So what I suspect has happened is that, as you know, the ground connection in an oscilloscope is shared between the channels. You don't have an isolated ground. So for example, if you want to measure voltage 1 and you put voltage 1 here and you put voltage 2 over here, the grounds are connected. So you cannot put two different potentials on the ground lines. If you do, they are shorted, and you're going to sink current through the probes and through the instrument and back out of the other probe, and you're going to get a short circuit, as you can see here. So I suspect that whoever has done this either accidentally or wasn't aware of this fact and has tried to put a large voltage with a lot of current carrying capability at these probes and have shorted them out and subsequently basically melted the probes. But if the probes are damaged, it's surely the scope itself must be damaged, because this is quite a bit of current to melt the ground shield on these probes. So anyhow, I'm not going to use these probes therefore for measurement anyway, because if I do, then I don't know if the cable is damaged. So we're going to get rid of these at least as a variable in analyzing this. And I'm going to go ahead and try and connect the inputs over here, which are up here, channel 1 and channel 2. I'm going to directly connect them with a BNC cable to, let's say, my function generator, and it would be kind of nice to use the Siglent SHS810 100MHz to generate some arbitrary waveforms and put them into here, see if they display anything on both of the channels. Then one of the nice things is that both channel 1 and channel 2 are on 0. So they're not stuck on high and stuck on low. That would be a classic sign of a damaged digitizer at the very input of the unit. So that's the fact that they're right in the center is a good sign, and hopefully that means that the problem is not too severe. But that, I think that kind of leads us to a path. First, let's connect it with the BNC and see what it looks like. So let me show you something. I've gone ahead and actually plugged the unit to the wall so we can run it from the external power supply. And look, all I'm going to do, I have a BNC cable here. The two ends are free. I'm going to leave one end on the table, and I'm going to go ahead and connect the other end directly to channel 2. Look at this. Remember, there's nothing on this side, huh? And if I go ahead and disconnect this unit from the AC supply, this signal gets significantly smaller. This is a classic grounding problem, because if there is no proper reference ground, as soon as I connect the oscilloscope to the wall, then you have a reference with respect to the 60 Hz that's all around me, and the ground is picking up a whole bunch of signal. And normally the BNC would be a fairly good insulator, so I shouldn't see that if I just have a BNC that has its end floating. I shouldn't have such a bad signal. If I have such a bad signal, then the grounding of the oscilloscope is heavily compromised, and that is That makes sense in conjunction with what we saw with the probes, because the probes have their ground melted, which means that a huge amount of current must have flown through from one channel to the other, most likely destroying the grounding that's inside the instrument. And that is consistent with this particular measurement that we see here. And if I go ahead and disconnect this guy, you can see it becomes significantly better. Normally, if you have an oscilloscope and you connect a probe to it, if you touch the tip of the probe with your finger, then you will see this. And that's because you have your entire body picking up a signal. But if there's a BNC with nothing connected to the end of it, you shouldn't see that because it should be fairly shielded. So that is a classic problem that we can see with something like this. So let's go ahead, take it apart. I mean, we were going to take it apart anyway. Now we can take a look inside. Here's the first part of our disassembly. The battery I've disconnected from the connector here, and this is a 7.4 volt 5000 milliamp hour battery, lithium polymer. And yeah, it's interesting. It's got only two points of contact, so it should be internally balanced somehow when it's being charged, otherwise you couldn't do this. But anyhow, pretty nice. Let's move forward. And here we go. I took the top cover off. I guess the handle should come out. There it is. Yeah, it's got metal inserts for the screws, which is nice, and it has to have that because the fuse is on the inside of the unit. So that's the only way to access the fuse here. Here are the terminals for the multimeter there. The 10 amp input doesn't have a fuse, and the fuse on the 600 milliamp input is unfortunately glass. And there it is. Again, a closer look at it. There we go. You can see the terminals from there. And I should be able to change the color and flip this around. Someone surely must have take this apart and have done this. I'd be surprised if that's the original one. But here you go, you can see very, very thick solder assisted thicker joint here for the ground terminal over there. And here's a 10 amp, and whatever the connection to the 10 amp is underneath on the other side. I cannot see it from here. And we can see some protection circuitry once we open it, hopefully. There's some relays and so on over here, a transformer here. I'm not sure for what, perhaps for the backlight display. I don't think the backlight is LED. I think it's still a kind of a fluorescent tube type. But anyhow, we'll take it apart further and I'll find out. So this obviously acts as perhaps both a heat sink for whatever's underneath here, because I can see some thermopoxy, although this doesn't seem to be making very good contact with it, but I see some thermoputty, not epoxy, thermoputty underneath it. So let's go ahead and take a couple more screws in. And let's look. Oh, there it is. Never mind. Look at that. You see that? That is damage on the PCB from the ground terminal. So I'm afraid to take this off. It's going to look pretty bad. And this one doesn't seem to have any immediately visible damage, but clearly this has seen better days. And that makes sense with what we saw from the probe, the current going through here and coming back out. Anyhow, I hope this is repairable, because if the PCB is completely destroyed, we'll have to do some reconstructive surgery. Alright, we've taken that part off, and here is the thermal putty that I was talking about, and this seems to be in contact with the main processor here. This appears to be a DSP processor from Analog Devices. Here's some memory. Here's an Altera Cyclone FPGA, a Cypress, most likely memory. There's a lattice part there that must be a CPLD of some kind, and this is a part for the multimeter. It looks like it's almost an entirely independent module that's just plugged in on top of everything. This is where the battery connects, keyboard, screen, some more relays over here. This is the cable that is responsible for passing the high voltage to the tube that is the backlight. Like I said, as I said, this is a definitely not LED backlit. So it overall looks pretty straightforward, and I like the design. It's fairly, and look, they have gone ahead and scratched off the parts on these components over here, I suppose just to protect some IP or some design rights on these. I'm not sure if that's really effective or not, but anyway, that's one way to do it. And we're going to go ahead and take these apart as well. There we go. Whoa, look at that. You probably can't see on camera yet, but there is some serious damage over there. These are of course the shields for the analog inputs. They've done their job well, and then let me see, it should come up. There we go. There it is. Wow. Take a look here. There's a bit of explosion happening over here. There's also, I don't see much damage on this pin, but if I wiggle it, look, you see, it's not connected to the PCB anymore. And that's what I suspected. There is no grounding at all from the BNC connectors whatsoever. So that's surely going to cause some problems. So we have to see how bad this damage is and how whether it can be reconstructed and whether that's the only problem it has suffered. I suspect it doesn't have any other issues, simply because whatever happened from the high voltage or the high current circuitry that closed the loop here has gone through the ground. And it looks like the connection from the BNC to the motherboard has what has suffered the most. So it should be fairly easy to fix. It'd be interesting to take it apart one step further and take a look and see what's on the other side of the PCB and how bad the damage is, and then do some cleaning and move forward. Here we go. I went ahead and I took the module that's responsible for the multimeter section out, and you can see that there's some protection plastic over here. I wonder if they've taken care enough to, to have the Cat 3 rating. I'm not going to go into too much detail, but indeed there is a WH250 component here, which is a resettable fuse on the 10 amp line. So the 10 amp line is connected here to the resettable fuse before it goes out, and so before it goes into the circuit and is monitored and so on through this component. But which means that if you put more than 10 amp, at least this will give you partial protection. And this explains this. There we go. That should do it, I think. I forgot now which way was going on. There it is. Yeah, now the colors are correct. So it looks like someone has taken this apart, at least. I don't think that was from factory. But there's another thing, is that inside of this, you can see here, there's a whole bunch of residue. I wonder if that's because of the smoke that's now been deposited on the inside of the unit after the explosion has happened. But you can see a whole bunch of it here, see? I can wipe it off like that. That seems like it's deposited from that, because since this component, this part of the circuit is working, there's some variable resistors here, which I wonder maybe it could be used to calibrate it further, because it seemed like it's a little bit off cal. But anyhow, with an explosion inside it, who knows what has happened. But anyhow, we don't need this component, so for now I'm going to take these out anyway, because they're just going to fall out. Put them away. Now we just have to take it one step further. I'm very curious to see what's on the other side of the board and see how bad the extent of the damage is. And on this side you can see the USB port. There's a device and a host port which you can use to upload firmware into it and connect it to the computer, and there's a whole bunch of software that runs on the computer and communicates with it. So it's a nice instrument. So let's go one step more. Alright, after taking a couple of more screws off, this unit comes up. I hope you're sitting down. And this is what we're dealing with. This is a disaster. You can see that the soot from the explosion is covering most of the surface mount components, which appear to be all resistors, all over here and all over here. This damage is quite extensive, and the smoke has reached all the way up to here. The explosion pattern can clearly be seen from the leftover marks here, and you can see where the body was protecting, where there could be no deposition. This was where the back filters were there. So the EM filters at the back of the board. So these guys were sitting on top, and you can see that they have managed to maintain and to keep most of the explosion in place. And there's even some welding of PCB traces directly at the edge, if this thing would focus, directly at the edge of the cover. So this was a pretty nasty mistake, and it certainly destroyed most of the back of the PCB. Now, the extent of the damage is not really known until we completely clean it. So I suggest we go ahead and take this whole piece off completely by unsoldering or just removing, since it's already burnt up from the PCB. That will open up this whole area for us to be able to clean it up, and go ahead and use some acetone and some alcohol to get rid of this, and take a closer look at the PCB under the light and see if it's repairable. Alright, here we go. Removed the BNC connector, so now all we're left is the board itself. I'm going to go scrub this and clean it up a little bit more, brush it off. Actually, I'm going to let my girlfriend do this part of it. She loves brushing PCBs. Ouch, she just punched me. There we go. So let's go ahead and figure this out, and after we clean it, we can assess the damage better. So this is as much cleaning as was possible. All these burn marks are now embedded into the solder mask and could not be taken off anymore. The resistors are a little bit more clean over here, but this is all basically soot that's damage that's left off. But if you look carefully, you can clearly see the path. Interestingly enough, there is 1, 2, 3 holes which are all ground. This is the hole that used to be connected to the BNC, and it's just vaporized, and that's what's deposited everywhere. This was the other one that was connected to the ground, also vaporized. You can see this whole trace over here is gone. There's some exposed copper here. There's some exposed copper here. So I'm going to do some reconstructive surgery here, and I'm going to rebuild this trace with aluminum, with copper foil, and I'm going to put it all and solder it all up together, so it's going to look nice just like it used to be before. And I'm going to do the same thing there, and that's my cat in the background. Thank you very much, Pooch. Your help is appreciated. And then now we can continue to do this and build this over here and build this over here, connect it all up, and see if we can get it to come back to life. I looked at it a little bit under the light too, and really this is the only piece, the portion of the ground here. You can see it's better marked here. This is all ground. So if we reconstruct this and reconnect everything and solder the ground back, solder the signal back, and we can test it to see if it comes back to life if there is no other damage. It's unlikely, but it is at least worth a try, because without the ground reconstruction we have nothing. And then we can test it if it works up to 100 megahertz and see what happens. There's a whole bunch of other components here, and you can see, of course, relays and other protection circuitry here. These relays to switch the range of the input. When on the vertical range, there's some variable capacitors here and here and here, and those variable capacitors are of course for tuning and dampening and getting the frequency response correctly. I would be interested to know what the difference between this model and the 200 megahertz version is. That would be an interesting thing to take a look at perhaps later. But first thing, reconstructive surgery. Let me do this here with the help of my girlfriend and see what we can find out. Maybe it looks nice, and I'll show you. Alright, here's the result of the reconstructive surgery. You can clearly see that we cut a piece of copper tape, and we have exposed the copper as much that was left underneath it, so that it's soldered on both sides, and you can see that it continues to the ground on this side, continues into the ground this side. This whole area is now ground, providing us with a good RF ground like before. Same on this side, you can see is all covered up, and it continues the ground forward. This is the RF input. This is the RF input. Now, interestingly, like I said, there was a symmetric ground point here. So what I'm going to do is I'm going to flip the connectors around by 180 degrees and use these as grounds. Even though we fixed this, now we're going to have a nice solid ground, but we don't have to puncture through this anymore. We're just going to use this hole and this hole, which are all connected together anyway, as our ground connection, and then connect it up and see if it comes back to life. And here's the finished part. Here you can see that we have soldered the center pin of the RF connector back to the board, and the ground is now flipped to the other side. This is the damaged pin that doesn't have any more pad on it. This is the other damaged pin that has no pad on it, and you can see that by flipping the connector we can utilize the other ground connector. And of course on the other side we have our extended ground connection all around, enabling the ground to be nice and solid. There's not yet known if any of these components are damaged, but you know, we'll see. The only way to find out is to power it on. So we'll have to assemble it a little bit more before we can go ahead and do that. Alright, one step closer. Now it's back in the case, and we're going to continue assembling it, and hopefully it will work. Alright, all back together. I'm turning it back on, and I've actually plugged it in as well. I closed it up. Everything back to the way it was, and it's still booting. There we go. There you go, back to the oscilloscope screen. Now it's plugged in, and let's go ahead and plug some PNCs into it. Let me see if I can get this PNC out of here. Plug into channel 1. There we go. See? That's much more promising. You don't have those crazy waveforms anymore. With a floating ground, there's 2 channels, channel 2. So far so good. And now we can go ahead and connect to our arbitrary waveform generator up here. Now I have set the arbitrary waveform generator to 1 megahertz on both outputs at 2 volt peak to peak into high impedance, and I've also put them at 90-degree offset. So plug this one in here, plug that one in here, and oh, damn it, I did this not the smartest way. There we go, we can still see it. There we go, let's go ahead and enable the outputs. Output 1, take a look. Isn't that beautiful? Look at that. Perfect. I can change the time base. Let's see. I hope you can see this. I don't know how well it shows on camera, but there it is. There you go. Have a better look at it. You can see. No problem. I can also change the vertical scaling, which is really important because there are relays that will switch in and out for different levels of attenuation. So for example, I can go up. You can see that it has no problem. I can go down. And then there was a relay that just clicked. You can see that the other relay clicked on the other side too. So I can go ahead and change the output level to 1 volt peak to peak on one channel. There it is. You can see that it has no problem capturing that. I can go ahead and do the same thing. You see, no problem. I can make it even smaller. There you go. Now it's 50 millivolt peak to peak. I can make it even, let's make it 250 millivolt peak to peak. No problem at all. You can see it has no issue picking up much smaller signals. Looks good. So what I really like about this repair is that, first of all, this was a good demonstration of what can happen if you in fact make a mistake and don't take into account the fact that the ground of the oscilloscope is connected. Now, this could have also led to an injury if somebody had touched the ground on the other probe and while the other ground was connected to high voltage. So that's a good lesson to learn. The other thing I like about this is that I needed no equipment to repair this. I didn't need any fancy components or anything. I just used a piece of copper tape, some soldering skills, and that was it. And you can bring it back to life just like that. So it's a really nice, basically introductory beginner type of repair. And it was a nice quick video, and you got to see what's inside the SHS810. I like it. It's a nice unit, you know. I think it cost about $540 for this particular model, and they have several different models. Maybe we can open it up and take a look at another one. I'm trying to keep this video short. So I'm going to thank my girlfriend. Come on, say something.
Hi.
That's it?
Yes, Shahriar does have a girlfriend.
There you go. See, that's the only thing she wanted to say. She wanted to make sure that you guys don't think that my cat was my girlfriend. Thank you very much. There it is. So I hope you liked it. If you liked the video, give it a thumbs up and leave a comment. Let me know what you think. And yeah, that's about it. Until next time.